Hi, this is skill 13.1 um, on exponential functions. So, intro to it. So, when we find inverses, is to switch the input, which is x's, and the output, which is y's, and then find the inverse of them. So, for example, something like this is growth and looks like the graph right below it. But let's think about what it would look like if I were to switch x and y's. So I'm now going to rewrite that, switching x and y's. And my points would also switch. And then it looks like this chart over here or this graph. Notice how none of this is negative. Just like here, I didn't have any negative y values. Here I can't have any negative x values. However, it's weird for us to see things this way, so this is where the ideas of logs are helpful, and we'll talk about this at the bottom of this page. But we write this as log base 2 of x, because we're used to having y by itself. So this is weird to get y by itself, so we have to use this idea of a log. We have logs to help us find the inverses. Okay. So the name of an inverse function of an exponential function is a logarithm. When we write the inverse as x equals 2y, this is not helpful. This is not helpful because y can't be isolated. So we rewrite it. So this becomes this when we take the inverse. And then we rewrite it so that y is by itself. So if we look at the bottom, this shows a conversion. Y equals something to the something. When we take the inverse, it becomes this. So flip to the back page. And it's the idea of a loop. So we're saying these are equivalent. X to the fifth equals 25 is the same. X equals log base 5 of 25. We have this idea of a loop. So we're saying x to the fifth equals 25. Or 5 to the x, sorry, equals 25. We're going to jump down to these ones down here. So whatever our base is, this is log base 2, 2 to the fifth equals 32. 4 to the 1/2 equals 2, because that's the same as square root of 4. If you want to see that, like 4 to the 1/2 equals 2, that's like saying square root of 4 equals 2. 2 equals 2. Here you're saying 2 to the negative 4 equals 1 over 16. 1 over 2 to the fourth equals 1 over 16. So really, when we rewrite this in exponential form, the answer is just this like our answer is, that is that equation in exponential form. So whatever our base is to our power equals our other side. So x to the z equals y. Here it wants to convert in log form. So you're kind of thinking the opposite. This is going to be my base. Whatever my power is going to be on the other side. And so if it's helpful to think 5 to the 4th equals 625. This is a base 4. So 4 to the negative 3 equals 1 over 64. Whatever is my exponent is going to be by itself. Whatever's my base is going to be small. So 9 to the 1/2, or 81 to the 1/2 is 9, or otherwise square root of 81 is 9. X to the y equals z. So now it's asking us to evaluate these. There's a couple ways to think of this. So say, this is saying 3 to x equals 27. So 3 to the x power equals 27. So 3 to what power is 27? 3 times 3 times 3 is 27, so x equals 3. 5 to what power equals 25? If it's, yeah. One half to what power is 1/8? 1/2 times 1/2 times 1/2 is 1 over 8. So that means that x is to the 3rd power. So we're just doing this loop thing. This is a little different. I'm going to think of this as three to the negative x. So we know that this whole top part needs to be a 2. So it's like negative x needs to equal a 2. So x equals negative 2. This is saying 6 to what power equals 6. Think of it, it's like a 1 there. So x equals 1. This is 8 to what power equals 1. Anything to the 0 power is 1, so x is going to be 0 there. If I loop this, sorry, you guys should have space on yours. This is saying 2/3 to the x equals 8 over 27. So you're thinking 2 times 2 times 2 is 8. 3 times 2 times 3 is 27. So x equals 3. Another way to think of this is 2/3 times 2/3 times 2/3 equals 6/27. Last one, we're thinking of 4 to what power is -16? Sorry. This is not possible because a positive 4 times anything is going to be positive. Another way to think of some of these, I'm going to do in a different marker. If you feel like you understand this, feel free to move on. So something like this becomes 3 to the x equals 27. I'm trying to rewrite both of these with base 3. So 27 is 3 to the x. When I look at this, then x equals 3. So if thinking of something this way, what I'm doing in green helps, that's totally fine too. I'm trying to write both of these base 5, and then I can just know that x equals 2. If that helps. Okay. Good luck, your IP is your next class. Let me know if I can do anything to help.